right, good morning, everyone. It's good to be back. Sorry about that. We had 2 days where I canceled, then the weather canceled, then we already had a break scheduled. Just kind of give you guys a little bit of a spring break there. So we are on schedule. We haven't had to make any modifications to the schedule this semester. Everything's going pretty well according to plan. So, like I say, you missed the 2 lectures. They're on my YouTube channel for customer relationship and supply chain management. We're going to pick up today, though, with Chapter 8, which is wireless mobile computing and commerce. So we're certainly going to cover that. Next class, we will cover Chapter 6. That's basically the last lecture for the semester. Then the 15th is the last day of class. We'll have the Technology Guide 3. Be pretty brief with that. I think that's the cloud computing one, as well as I'll give you all the opportunity to ask any questions you have from anything in the course. So just to kind of take a quick look at this. Gotten some questions about the exam. It is cumulative, so you'll see here pretty much anything that was covered. Fair game for the final. You should have a list of every term. I think that's inside of Canvas as well. Let me just double check that real fast. So yeah, this document right here lists all the terms you can see on the final. Well, I'm going to say most of the terms you'll see on the final. So certainly make sure that you look over that. If you have any questions, I'll send out a link in a couple days to address during the review. You can also attend it in person. Of course, you can ask questions face to face, but I imagine most people would probably rather just put it on the survey and then I'll address them. Any questions I can address right now? I'm always happy to take any questions. Apart from that, I did send out a link that is for the McGraw-Hill. They want to do a survey to see what you guys think of it. If you complete it, I will award you 2 points on your final grade. So this is pretty much the only time that you'll have that opportunity to get points for your final grade. So I'd highly recommend you do that. 2 points could certainly be the difference between an A and a B and a C, and so forth. So just make sure you do that. Make sure you use your Mississippi State email address. That's really the only identifying information that I have access to. So just make sure that you do that, and make sure you do it before midnight tomorrow. So, apart from that, go over the due dates real quickly. We have the final Connect Master coming up. It's going to be next Tuesday, 11:59 p.m. Then on the last day of class, the 15th, we're going to have the Chapter 3 quizzes, or Unit 3 rather. So those 4 chapters from Unit 3, quizzes are going to be due. Then the final exam, like I say, it is mandatory. It will count at least 20% of your grade. It can count up to 40% of your grade if it's higher than either exam 1 or exam 2. So I'll just calculate it those 3 ways. Whichever's highest, that's going to be your exam average. So you can take it anytime you want. Once you open it, you have 3 hours to complete it. It'll be available the entire testing window, which is April 22nd through April 28th. Like before, I'll probably apply at least a 5% curve to it, possibly more, depends on how the grades were. It seems like on exam 2, I ended up applying maybe a 7-point curve to it. I'll look at the grades and I'll apply a reasonable curve, so don't worry about that. And I'll also apply any bonus points that you've earned, so it should be pretty straightforward. Any questions? Well, all right. Well, then today we're covering Chapter 8, which, like I said, is going to be the wireless mobile computing and commerce chapter. So as you may anticipate, we're going to be covering a lot of stuff dealing with wireless computing, particularly looking at how they make sense from a business standpoint. Why do we use wireless communication? We'll also be looking at mobile computing just a little bit. We already had a mobile commerce chapter, so probably not going to go too much into this. And then also Internet of Things. So just kind of get started. We're going to talk about several different types of wireless technologies. The first being Wi-Fi. So as you'd anticipate, Wi-Fi stands for wireless fidelity. It's going to be used for network communication with various devices, laptops, in some cases desktops, mobile devices, anything like that. It's going to allow organizations or individuals to set up a wireless network of connected devices. This kind of contrasts a little bit with radios. So there's two types of, well, there's more than two types of radios, of course. Two major distinctions. Technically speaking, anything that transmits wirelessly is a radio by definition. But in this case, I'm referring to like a shortwave radio, where you're basically communicating via voice in an analog fashion. It's going to be usable in some cases, but in other cases, it wouldn't make sense to use a radio. So this is something to think about. Cellular, of course, is another type of wireless network. It's going to be managed typically not by an individual. Typically, it's going to be managed by a large party. And it's going to allow for communication for miles, basically. So you can be miles away from a tower and still communicate. Not true of Wi-Fi. Then lastly, we have satellite communication. Satellite communication, of course, can be worldwide. In most cases, some minor exceptions being if you were underground, probably not going to be able to get satellite signal. But for the most case, they're going to be pretty similar in terms of what they can do and what sort of advantages they can have. So speaking of those advantages, the main one is going to be the scalability. So if you think about a traditional wired network, you have a limited amount of ports. However many ports you install, that's how many ports you have. Really, the only way to upgrade that would be to install more ports. That's physically intensive. It's also intensive to the building. So, imagine a room this size. Let's say that we wanted to put a wired network in here to where every single seat, I think there's 375 seats in here. That's 375 ports. That's going to be pretty costly. That's not going to be something we're going to be able to easily do. Not to mention, what are you going to do with all the cords? So, can you imagine trying to walk through the aisles if there are, let's just say, 20 cords in the aisle? Is that safe? Not very safe. So, in some cases, a wired network is preferable, but not in every case. Wouldn't make sense to have a wired network established for each and every person in this room, simply because it's going to be dangerous physically, and it's also going to be costly. Not to mention, think about the port damage. People constantly plugging and unplugging, people tripping over cables. It's going to damage the ports. So the maintenance is also going to be pretty substantial. It's going to contrast with putting up a wireless access point. I'd say that probably 2 to 4 wireless access points can easily service, let's say, 200 or 300 people at a time. It's not going to be a problem. We have 2 mounted right there, and you get wireless service in here. I'm assuming you don't have any major problems accessing that. But if you did, certainly, that's something that we could address pretty easily by just replacing 2 or 3 access points as opposed to ripping out an entire infrastructure that's wired in. Another consideration is think about a historic building. Can you just go into a historic building and start moving walls, and then you deal with plaster, and it's just a big pain. So in a lot of cases, it's going to be very beneficial. We talk about the cost of entry. So typical enterprise wireless access point is going to run you anywhere from, I'd say, about $150 upwards of $300 or $400. And that's going to be able to service roughly 200 people, maybe 100 depending on the type you're getting and all that. But basically, it's going to be a lot cheaper, a lot less expensive to sort of enter the market. So certainly, or just enter it in general. So those are the main sort of advantages there. Like I say, looking at any sort of cord, we'll talk about this more next class, but pretty much any cord we're using only has a 300-foot range. We can pretty much match that with any wireless access point we have. Sometimes we can get a little bit more than 300 feet, but we're pretty much always going to be able to match it. And then you don't have a big cord that you have to worry about. So, any questions so far? All right. So kind of speaking about the sort of threat of new entrants, this is, of course, Porter's 5 forces. We're looking at rivalry. So if we can reduce the barriers to entry, we're going to increase the rivalry inside of an industry. So this is particularly interesting for something like a wireless internet service provider, where they're competing with traditional internet service providers. So think about Comcast, think about some of the other internet service providers that we have. Imagine if you could simply put up a very powerful wireless access point and provide internet service to people. Now in this case, this would probably not be using an actual access point, probably be using microwave technology, where you're going to have line of sight and point-to-point established. But you don't have to have the physical cable infrastructure. So we talked about cable infrastructure within a building. Imagine working it out with the various utility companies that own the utility poles. Is that going to be cheap? What if you have to bury a cable? Is it cheap to get permits to bury a cable underneath a public road? It's not uncommon for it to run in the millions of dollars to go just 1 mile. So if you can use wireless technology, it can certainly be an advantage. Now we'll talk about some disadvantages here. The main one being that there's going to be lots of interference. So if you were to have a wireless device, other people have wireless devices as well, that can cause some interference that can certainly lead to issues in communicating. Then of course we're talking about microwave technology. We have to have that line of sight. Are we going to be able to get that? Yeah, possibly. Certainly within their own possibility. One thing to keep in mind, of course, the Earth is curved. So it's very difficult to go more than 10 miles with any sort of line of sight, because once you go that far, you have to be pretty high up to be able to still be able to see past that. Of course, you also have trees, you also have buildings. Just a lot of stuff can cause obstruction, so it can be difficult to obtain. But if you can obtain it, it's almost always going to be cheaper. Of course, you have the latency to consider. So when we talk about latency, what we're saying is the time from when we send a signal to when we receive the signal. So that's going to be expressed in milliseconds. Anything larger than, say, 10 is going to be somewhat noticeable. So we definitely would want to avoid latency. And going over microwave, we're going to have inherent latency with that. Then also we have the appearance consideration. Not everyone cares, but some people certainly don't like the appearance of any sort of wireless device. There's people who complain about cell phone towers. There's people who complain about microwaves on the side of buildings. Whatever people are complaining about, not everyone's going to like it. So how do you as a business person sort of work through that? Well, I don't know. There's a lot of different options. There's certainly technologies where we can sort of mimic other things. It's very common with like a flagpole to be able to have a cell phone tower in it. Sometimes they try to make them look like trees. Or you can just stick one up and say, fight me. There's lots of different options. I'm not saying which one is right or which one is wrong. It's really up to you. So here's some of the general advantages and disadvantages. I'm not going to go over these too much because we pretty much just did. So microwave is going to be very high bandwidth, but it's going to have point-to-point. It means you're going to have two devices basically devoted to each other, which if you had, say, 1,000 clients, that's going to be quite expensive because that's 2,000 devices. It's also going to have unobstructed line of sight and very easily to interfere with them. So we can kind of see this. Infrared's another technology that requires line of sight. It's not going to be used for much more than a remote nowadays because it's not going to be able to be transmitting very much information at a time. It's literally a light signal. So certainly keep that in mind. We're not going to do too much with infrared or anything. But satellite is certainly one that's growing in popularity. Traditionally, it's been used for TV in some cases. But we're actually seeing some various satellite internet service providers launch some pretty interesting services. Anyone who follows Tesla and SpaceX, they're certainly launching some very exciting service for people in rural areas who maybe otherwise wouldn't be able to get usable internet service. So speaking of satellites, three major things to know here. We have the geostationary orbit, which is going to be the one that's furthest away from Earth. As a result of it being furthest away from Earth, we can have the fewest number of satellites provide service to the Earth at the cost of those satellites are going to be a lot more expensive to launch. Because if you're launching something for, say, 10,000 miles, it's going to be more costly than if you're launching something for, say, 600 miles. So while you have fewer of them, you certainly have to have a higher cost per satellite. Then we have mid-Earth orbit. It's going to be the second closest. And in mid-Earth orbit, it's kind of in between. And then, of course, we have the low Earth orbit. So low Earth orbit is going to be the one that's very close to Earth. It's going to be roughly about 400 to 600 miles from Earth. So you have to have lots of individual satellites, but it's going to be cheap to launch those satellites. So, of course, that's also going to have a lower latency than either mid-Earth orbit or geostationary. So pretty much, just think about if you have a flashlight and a globe. And if you shine the flashlight on the globe and you're very close to it, you're only going to cover a tiny little portion of the globe with light. But if you shine the flashlight from a ways away, you're going to illuminate a lot more of the globe. Does that make sense? So Just kind of keep that in mind. That's what we're talking about here. So we already talked about SpaceX, some wireless threats. Wireless technology is kind of interesting. It's not limited to your physical space. So if you put up an access point, chances are it's probably going to extend beyond your physical walls. So what does that mean? Does that mean that anyone can sign in and access all your data? Hopefully not. And if you're using any sort of reasonable encryption, it doesn't mean that at all. So one common threat would be a rogue AP. So a rogue AP is simply an access point that is established by unauthorized measures. So it's a very common term where basically someone says, I don't get good wireless access inside of this space. I'm going to set up my own access point. So plug an access point in, set it up, you're good to go. And that's considered a rogue AP because it's not established by whatever sort of central IT department you have at whatever organization you're dealing with. So these can be a big problem because imagine if someone uses a same SSID as you and you're not using certificates to authenticate that it is in fact whatever network you believe it is, then they could of course access any data that's going across the device. So that could be a big problem. Because that's really, if you're not using a certificate, nothing stopping anyone from establishing a fake network. Literally nothing. So certainly keep that in mind. Then we have war driving. That's another threat we could see. So instead of war driving, what we would do is we would actually go around physically. You can drive, but you could also walk. Just because it has driving in the name doesn't mean you have to drive. Basically what you're doing is you're scanning to see what wireless networks are around, what sort of security they're using, what sort of protocols they have open. Anything like that, you're trying to collect information to sort of see how we can best access a network. Imagine we drove by a bank and they were using an unsecured wireless network. Could we get on the wireless network and snoop? Yeah, we could. Should we? Probably not, but we could. So eavesdropping. Eavesdropping is going to be both physical and, in this case, I'm talking about sort of packet sniffing, which is referred to as eavesdropping as well. And what you're doing here is you're just basically going onto a network and you're seeing what goes across it. You're physically examining the packets. That can, of course, get you important information, but in the age of SSL encryption, you're less likely to get anything usable simply because almost every site at this point is using SSL to encrypt the traffic between the device and the host of the website. So probably not likely to get anything nowadays. 10 or 20 years ago, this would have been a great trick. And then lastly, we have RF jamming. So RF jamming is going to be used pretty commonly in terms of making sure that people can't communicate wirelessly. So what you're doing is you're getting on the same, whatever the RF frequency is for the device, getting on that, and you're just broadcasting junk noise. So it's not audible noise, of course I'm talking about, the same RF frequency. This is very common with things like cell phone jammers. Some people, it comes out every once in a while, someone uses them inside of a movie theater. They don't want to have people on their cell phones while they're watching a movie. And that's something that is illegal, at least in the United States, for several reasons. The main one being, what if someone needs to communicate with emergency services? They'd be unable to do so. But this could be used for a lot of different things. It's not limited, of course, to cell phones. Very common use of them is something like a radar detector and radar jammer. So of course, if you are going down the road, maybe someone is clocking your speed for whatever reason people clock your speed for, make of that what you will. You could of course use a radar jammer. Of course, you'd also want to use different types as well, like LiDAR as well, to just ensure that people aren't able to get your speed. Now, in almost every state, that's considered illegal as well, so I'm not recommending it. I'm just saying it's possible and it is done. Does that make sense? I don't want to give anyone any illegal advice in here. Talk about Wi-Fi a little bit. It's going to be the IEEE 802.11 standards. Of course, this is a little bit outdated because this has AC as the latest. Of course, now we're on Wi-Fi 6, which is even faster and more secure than before. But basically, all you need to know about this is as time progresses, wireless gets faster and supports more devices in large range and all that sort of stuff. So the one exception is 802.11a and 802.11b both came out about the same time. They were kind of developed in competing labs, and A is using 5 gigahertz, so it's a little bit faster, but the B is using 2.4 gigahertz, so it's able to have a larger range, because in general, 2.4 gigahertz is going to be able to penetrate walls better and provide better coverage, but it's also a lot more stuff using 2.4 gigahertz, a lot of household devices, even a lot of the old-time phones where they're wireless using 2.4 gigahertz. Just a lot of things do. So there's going to be a lot more interference, and it's also a smaller spectrum in general than 5 gigahertz. So generally speaking, 5 gigahertz is going to be preferable for Wi-Fi if it can be used, but not every device supports it. It is more costly to acquire a 5 gigahertz radio than a 2.4 gigahertz radio. So that's just a general thing to know, is that the speeds are going to increase. Other common devices that use wireless, of course we have Bluetooth. You can do lots of things with Bluetooth. Certainly you can transmit audio quite easily. You can transmit files in some cases pretty slowly, but still can be done. NFC can also be used to transmit payment information quite commonly. Some cases it's used for inventory. I think we have that in a couple slides here. But basically the whole concept is that we're easily transmitting small bits of information. Same thing with Zigbee and ZWave. Those are both going to be used to transmit tiny bits of information. Both of those are using a mesh network in which there is no central device. They just kind of all communicate in a mesh fashion, and it's going to be beneficial for having low power transmission, but it's going to be not as beneficial because there's a lot less security involved with those two protocols. So very common inside of a lot of smart home devices. We've got that in a couple slides here. So talking about NFC, of course, one of the biggest uses is going to be the mobile wallet. Google Wallet and Apple Pay both use it. You could certainly do lots of different things with mobile commerce. Particularly common is things like location-based applications. You know, if you were to go on some apps, I think Foursquare, I don't know if they're still around, they used to be pretty well known for this, where you check into places. You know, you check into the bank, you check into church, you check into school, whatever you do, check into Walmart. You could certainly check in, and in some cases you'll be able to get discounts. That's quite common, and you know, maybe you drive by a Starbucks, you get a notification, would you like $1 off of a Starbucks? Something you could see, something like that. Mobile advertising is very prevalent on social networks, mobile websites, YouTube, anything like that. It's going to be quite common. And then lastly, of course, we talk about telemetry. I think we talked about this in the ethics and privacy chapter. The whole concept is the telemetry being that you're sending information. You know, you're sending information, you're receiving information. So if you have some sort of thing that you're interested in, it's going to be going back to the advertisements. They're going to be sending you advertisements about it. Quite common. Of course, ways to avoid this are to not be interested in anything. No, I'm kidding about that. You know, you could certainly use private browsing, incognito browsing, whichever option your browser calls it, and you could certainly avoid having a lot of that information stored about you. So inventory tracking. This is a very interesting topic. Basically, there's a couple different ways you can do inventory tracking. So first of all, we talk about what is inventory tracking. We have physical inventory of products. Let's say we're a retail store, and we want to know how much do we have, because we want to calculate how much shrinkage do we have. Shrinkage, of course, being another term for lost merchandise. It can have several causes. Could be a product was damaged. Could be that a product was stolen. Could be, am I missing anything? Well, just think of shrinkage as being we don't have the product anymore that we thought we did. So we want to calculate that. We do inventory. A couple different ways we can do this. We can use RFID, where basically each device would have an RFID. And we could literally take a whole pallet running underneath an RFID scanner, and we could see exactly how many tags we had and what those tags were tied to. So that's going to be a very beneficial way. It's probably going to be certainly the easiest and most effective way, because, like I said, you can literally run an entire pallet through a scanner at once. You can't do that with a QR code or a barcode. So a QR code, of course, is going to be a code that's going to have just a lot more information than a traditional barcode would. And it's going to basically allow you to do the same thing as a barcode, though. Of course, a barcode, most famous example, that's going to be the universal product code, 12 characters. It's going to be on pretty much every product, and it's going to allow you to quickly and effectively scan it. But like I said, you have to have that physical line of sight to both a barcode and a QR code, whereas you don't with an RFID. So, any questions about that? course, another way to track inventory would be pen and paper. What's the problem with pen and paper? It takes a long time to do that. So generally speaking, these are going to be the three most common ways to track inventory in any sort of large-scale establishment that has a lot of physical products and services to track. So IoT uses, there's a lot of different ways we could use Internet of Things devices. We talked about smart homes in here before. Healthcare. It's very common to have various sensors and stuff on a specific network inside of a health facility to easily provide alerts if someone's vital signs are not ideal. They can certainly get alerts and go check on them. Just kind of having that for legal reasons as well. So certainly it'd be a good thing if you're getting sued to be able to say, well, no, we did actually check on the patient X amount of times. Here are their vitals throughout the entirety of their stay. All that sort of stuff would be very beneficial for a healthcare facility to have. Automotive, it's very common for them, especially in some of the larger devices, to use Internet of Things for things like diagnostics and other sort of purposes. Supply chain management, it's very common for a lot of the sort of supply chain things to use Internet of Things to just keep track of inventory, keep track of where products are physically located at any given time. Environmental monitoring, it's very common as well. They have tons of soil sensors, checking on the weather. Imagine if you had to physically drive out every hour to every sensor that you had. That'd be impossible. So, of course, it's very good to establish an IoT network to have them all communicate to a central location. It's going to be very affordable, and certainly it's going to make the operating costs much lower. And lastly, agriculture. Just like with the environmental monitoring, doesn't make a whole lot of sense to go check on the crops all the time, how much soil's in the water, whatever else they need to check on. I don't know, but there's a lot of different things that we can check on with having small sensors that communicate to a central authority. Here are the two major standards. Really, there's only one thing you need to know, is that ZWave is sub 1 gigahertz. It typically operates around 800 or 900 megahertz, whereas Zigbee is on the 2.4 gigahertz spectrum. So generally speaking, it's going to have a lot more congestion on the 2.4 gigahertz spectrum. So for that reason, you may prefer Z-Wave. It's the only thing you really need to know. Just kind of wrap things up today, we talked about wireless technologies. We covered mobile computing, as well as Internet of Things. Any questions? All right, well, it's a shorter day today. Next class, we will talk about computer networks, and that'll be the final lecture for the semester. We will, of course, have the review day if you'd like to attend that. But apart from that, hope you all have a great day.